In this video, you'll learn about one of the most diverse ecosystems on the planet, coral reefs. But what are coral reefs? Coral reefs are large, underwater structures made up of living and old deceased coral. Coral is a living animal called a polyp, which is closely related to anemones and jellyfish. Coral has lived in Earth's oceans for at least 240 million years. The reef is the result of thousands of different varieties forming a colony together. As they live, they absorb energy from the sun and secrete calcium carbonate, forming the bones of the reef itself and providing shelter for many species of fish, algae, invertebrates, and microorganisms. There are over 2,500 different types of coral. Though it would be difficult to memorize them all, they can be broken down into simpler categories. The first is hard coral, made of hard limestone exoskeleton. It grows very slowly over time. Scientifically known as scleractinarians, such as the example of staghorn coral. Other hard corals consist of pillar coral, table coral, rain coral, blue coral, great star coral, tube coral, and elkhorn coral. The other broad type is called soft coral. Sometimes mistaken for plants, the soft coral are still made of limestone as the hard coral, but it is blended with protein and therefore less rigid. Swaying back and forth in the currents is possible as it lacks the hard exoskeleton, giving it its plant-like appearance. Soft corals consist of gorgonian, or sea fans, carnation coral, toadstool coral, tree coral, sea pens, and bubble coral. Coral reefs are located around the world in warm waters, mostly in the tropics. They prefer shallow water. Of these tropical corals, there are three major categories of reefs. Fringe reefs appear near the coastlines of major land areas and on continental shelves. When the ocean floor spreads or subsides, usually from volcanic islands, these fringes become a barrier reef. Consisting of enormous amounts of coral, the largest, the Great Barrier Reef in Australia, stretches over 1,600 miles. With further subsiding over time, the center volcanic cone sinks and the reef grows into an atoll reef, capable of sustaining plant life above water and forming a lagoon in the interior of its ring. Science has recently discovered other species of coral which reside in deep, colder waters. Known as deep-sea coral, though not as much known about these as their tropical cousins. They can be found closer to the poles near Norway and New Zealand, and can even exist in waters as cold as -1 degree Celsius. Coral reefs are very important to our oceans. They have a number of benefits to the hydrosphere, the atmosphere, and even the biosphere. One of the major things coral reefs do is protect coastlines. According to the World Ocean Review, more than 200 million people worldwide live along coastlines today, and approximately 500 million by the end of this century. Tsunamis and hurricanes have proven to be catastrophic events, such as Hurricanes Harvey, Irma, and Marie in 2017. Coral reefs can help prevent loss of life and property damage by buffering against waves, storm surge, and flooding. Another benefit of coral reefs is housing marine life. As colonies of coral develop into reefs, they become host to thousands of different marine species, from the smallest plankton, which aid in its food cycle, to larger fish, crustaceans, jellyfish, sponges, and of course sharks. Some of the highest biodiversity in the world can exist in coral reefs. About a quarter of the world's marine animals inhabit coral reef areas. Coral reefs also regulate CO2. As a result of coral's symbiotic relationship with algae, oxygen is produced for photosynthesis, and the coral in turn produces CO2. This carbon dioxide is excreted as a viscous liquid, and it aids in regulating the amount of carbon dioxide and pH level of the ocean waters. This balance can prevent ocean acidification and can affect how much CO2 is absorbed from the atmosphere. Large storm waves from repeated hurricane activity can damage coral reefs. Continued impacts of powerful waves over many years can greatly damage reefs and leave a coastline more vulnerable to flooding. Ocean acidification can cause coral bleaching events, which can kill coral or make it much weaker and more vulnerable to predation and environmental effects. Mankind's effects, such as dredging, destructive fishing, and coastal development, can destroy large areas of coral reefs, such as Florida's third largest coral reef in the world. Mankind can also contribute to ocean acidification due to pollution runoff, dumping, and offshore mining. All these effects could lead to the damage and possible extinction of coral reefs all around the world. But there is some hope. We can repair or regrow some coral reefs using a process called in-water propagation. By developing coral nurseries, we can artificially plant corals faster to repair damaged areas using fragmentation and reskinning techniques. Scientists can use genetic selection to replant species more likely to flourish in a particular environment, and have even used reef frames charged with low voltage of electricity. The resultant chemical reaction producing protective minerals similar to their natural limestone. In order to fight against the extinction of some coral species, genetic material is being saved in labs in the event of a catastrophic loss of coral reefs in the future. It is hoped that with this valuable material, our diverse coral reefs can be restored when global warming, ocean acidification, and pollution caused by mankind are no longer such a problem. In order to protect and restore our coral reefs, we must know more about them. Today, there are large efforts to map our existing coral reefs. A joint effort by NASA and NOAA, to name one, hopes to map reefs in less than 30 meters of water around the world. Other agencies and organizations around the world have also begun using technology such as GIS, LiDAR, sonar, sea-whiffs, and satellite imagery can help us build the most comprehensive map of our coral reef biome that's ever been produced.